Hey guys, welcome back. We're glad you came to join us for more SeaPerch fun.
Let's get started right away because there's lots we want to cover.
For instance, have you ever wondered why some materials are made from wood and some metal?
Or plastic or rubber? Before designing anything, engineers spend a lot of time thinking about different materials and their properties.
A material property is a quality or characteristic that helps an engineer figure out which material will work best for what they want to design.
There are a whole lot of material properties, like mechanical properties or electrical properties. Take a look.
And that's just to name a few. Each of these categories has a bunch of specific properties to go along with it.
Like if you look at mechanical properties, there are at least a dozen different specific properties to describe it.
Properties such as how strong it is, or how flexible it is, or even how much it weighs.
Right, like this piece of styrofoam.
Or this metal bar. Different materials, different properties.
Let's break them in half. I'm waiting.
This isn't exactly fair.
This is what happens when you have materials with different properties. Some break easily under pressure and some don't.
How about we just move along to the electrical properties?
Sure. Electrical properties relate to how a material reacts to or with electricity.
Like how well electricity will flow through an object.
And how it won't flow through some at all. Take a lamp, for example. If it's not plugged in, nothing happens.
But if it's plugged in, electricity will flow through the cord.
And the light lights.
Electricity is flowing through the cord right now, but because of the insulation, it's safe.
The electricity can't get through the insulation.
These are the kind of things that electrical engineers figure out all the time. They want to make things work while still keeping us safe.
Luckily for you, you don't have to worry too much about the materials used to build a SeaPerch.
The engineers at MIT have taken all this into consideration when they designed the original SeaPerch.
They've taken into account things like mechanical strength,
so that your SeaPerch is lightweight but still sturdy enough to withstand loads.
They've considered the electrical properties of the wire and control box.
These are designed perfectly to both power and control your ROV.
But there is one concept with the property that you definitely need to know to build and modify your ROV.
Buoyancy. Buoyancy is very dependent on the mechanical property of a specific weight or density.
The density of an object is the measure of mass per volume. Earlier, we conducted some experiments to help demonstrate how it works. Check it out.
Solid objects that are less dense than water will float, like this styrofoam ball.
But if we put a nail into the water, it sinks.
That's because the nail is more dense than the water.
The ball is buoyant, but the nail is not.
Buoyancy is the force from the water pressure which helps to keep an object afloat. While gravity pulls down, the buoyant force pushes up.
Archimedes explained the principle of buoyancy in the 17th century.
He said that the buoyant force is equal to the weight of the fluid or water that is displaced or occupied.
That's a little technical. Let's see if we can demonstrate.
If I drop this ball of clay into the water, it will sink.
But if we change the shape of the ball into something similar like a boat, it should float.
That's because the new shape of the clay displaces more water. Therefore, the weight of the water is now heavier than the clay.
It's less dense than the water, so it floated.
Exactly, or should I say positively, because in this case the object floated, and that's called positive buoyancy.
But if we put a little bit of water into the boat, then it should sink. And since floating is positive, then sinking is?
Negative buoyancy, exactly, you got it. So if it floats is positive, if it sinks is negative. Let's try it out.
Okay. Definitely negative. And it's easy to remember because it's a negative thing if your boat sinks.
Gotta love science.
And experimenting.
Now when it comes time, you're going to have to make your SeaPerch neutrally buoyant, but that's not till later on down the line. For now, remember the last time when we talked about the center of gravity?
It's the geometric location or point where all mass is said to be concentrated.
It helps to keep things balanced.
The center of gravity will help you to know how to make your SeaPerch balanced and stable. It's the center of mass of the immersed part of the ship or other floating object.
For example, if you have a boat, the center of gravity will be the geometric center of the boat, but the center of buoyancy will be the center of gravity of the displaced water.
This stuff is really important for you guys to know because your SeaPerch needs to be stable and balanced.
Stability is the property of an object to get back to its original position after it has been disturbed.
You don't want your SeaPerch to tilt to the side or have trouble staying upright. And objects tend to be more stable if you have a lower center of gravity.
That means you don't want your SeaPerch to be top heavy. If all the weight is on the top portion, it may not float properly and it may cause it to capsize.
But there are things you can do to increase the stability of your SeaPerch, like adding a ballast.
Ballasting is adding a weight to increase performance. You can add a ballast to either a boat or a submarine to increase balance or stability.
The ballast will also help to make sure that your sea perch isn't too buoyant. If it's too buoyant, then it will take a lot of energy for the sea perch to submerge, or even worse, it might not submerge at all.
Or, if your sea perch is negatively buoyant, you'll have to constantly run the motor in order to maneuver, and you won't have enough force to pick up objects in the competition.
Remember our styrofoam ball? As part of our earlier experiment, we determined that the styrofoam ball floated. But when we take a different styrofoam ball and add a washer to it, it sinks a little bit more.
Ballasting is the same idea.
Hope that gives you a better idea of how your ROV stays in the water. Next time we'll talk a little bit more about stability and buoyancy. And if you want to test some of the things we talked about today, your teacher has some experiments for you to try on your own.
But for right now, we're going to turn you over to Chris, who's going to show you the next part in building your sea perch.
See you soon.